All right, we're going on now to Chapter 6, Section 2. It's also dealing with rational expressions, but in this case we are adding and subtracting. And you might say, well, is that easier or harder? And the answer is it's a little bit more difficult. The reason being that in adding and subtracting fractions, which are rational expressions, we must have a common denominator. So we're also introducing least common multiple and least common denominator. Now, when the denominators are the same, such as if you have 3 halves plus 4 halves, this gives you 7 halves. The denominator doesn't change, you just add your numerators. But since we are in college algebra, it's more challenging than just that. So, strategy. The first thing you look at is, oh, they have the same denominator. So, what we do is we put x minus 1, that's our common denominator, and then we just put our numerator. So it'll be 3x plus x, and then 5 minus 9 over our common denominator. And then we end up with 4x minus 4 over x minus 1. And you might say, oh, we're finished. Well, no. Because look, you could factor out a 4 from this top and get x minus 1 over x minus 1 now. So these cancel out. And your answer then is 4. So we're, having the same common denominator makes it a little easier. You still have to simplify. All right, in example 6, instead of addition of fractions, we're having subtraction of fractions. And I'll show you the strategy for doing that. Again, it's over the common denominator of a plus 3b. And then we just write our numerator, 2a minus b. Now, you see this negative sign here. I'm going to make that positive, and I'm going to change this sign now to their opposite signs. This will become a negative. This will become a positive. So I've converted a subtraction to an addition by changing the signs. Remember, this is a grouping symbol, so you have to change both signs. You have to change both signs. And now we combine like terms. We got 2a minus 5a will be a negative 3a. A negative b and a positive 2b ends up with a positive b over a plus 3b. And remember, we said since these are like two terms, you can't put the negative here. Or if you did, if I put the negative here, this would become a positive, and that would become a negative. Or you could have left it as it was. For number 6, let's see what they have here. They had it as I originally had it. But remember, that negative sign is there. So let's take that away. Leave that as negative and leave that as positive. Okay, 7, they're continuing, but notice 7 now doesn't have a common denominator. We have to figure out what will be our common denominator for this series of expressions. Well, in a case like this, you could just use what you have here. It's going to be 2x and a x plus 5. This is what your common denominator will be. That is a combination of these. Now, in order to make that common denominator this, what did we have to multiply this one by? Well, we had to multiply it by 2x. And what did we have to multiply this by to make it this? Well, x plus 5. Now remember, 2x over 2x is 1, and we are allowed to multiply anything by 1, as is x plus 5 over x plus 5. So now we do our multiplication, and we get 14x squared here, plus 3x plus 15. Now, notice that as we do this, they also wanted to find out what would our domain be of our final answer. Well, again, it's taking each of these terms and equating them to 0. So here, for our domain, it would be any real number, but x cannot equal 0, or x cannot equal a negative 5. Okay, we'll have some more of these. This wasn't too difficult, but you can see where it sort of gets a little more challenging as we try to shoot for common denominators. Now in number 8, there is a common denominator here, and this is going to become just 10 minus 6. That's going to be a 4 over x squared. Well, let's factor that, because that's going to be x plus 1, x minus 1, our conjugates, and the values that would not be defined in the domain would be x cannot equal a negative 1, or x cannot equal a positive 1. So this one was a little easier than this one, but there's the strategy. Now, if this were an introductory level course, we'd be doing lots of least common multiples. And here they're just giving you these 2 examples, so I'll try to teach it as I would in a regular class. Now, in order to find the least common multiple of numbers like this, we use what we call prime factorization. And this is how I do it. I'll say, what prime number goes into there very well? Well, a 3 and a 5. So there's my prime factorization of 15. Then I do 25. And there's my prime factorization of 25. Now the rule for finding the least common multiple is what is the greatest number of times a factor is used in any one factorization. Well, here we have a 3, and that's used once. So we'll need a 3 as one of our factorizations for our least common multiple. Now there's a 5 here. Here the 5 is used once, but the same 5 is used twice there. So the greatest number of times the 5 is used in any one factorization is twice. So we multiply these. 25 times 3 is 75. 75 is our least common multiple of 15 and 25. And we use that technique to figure it out. And then for our variables, it's just the highest exponent on the variable. So for this one, it'll be x to the third. Now, because this is something you may not have had for a while, let's look at this numbers now. We have a 9, we have an 8, let's say, and we have a 24. And we want to figure out the least common multiple of these three numbers. So let's do prime factorization. This is 3, this is 3. This will be 2, 4, 2, 2. And this will be 2, 12, 2, 6, 2, 3. Okay, these numbers out here are the prime factorization of these three numbers. Now, what would be my least common multiple of those three numbers? Well, you have a factor of 3, a factor of 2, and a factor of 3. So what is the greatest number of times that a 2 is used in any one factorization? Well, here it's used 3 times, so I'll need 3 of them. 2 times 2 times 2. Here it's only, well, it's 3 there and 3 there. So the greatest number of times in any one factorization is 3. And what's the greatest number of times that 3 is used? Well, it's used twice. Here it's only used once, but here it's used twice. So this is going to be 8 times 9, which is 72. So the prime factorization of 9, 8, and 24 is 72. And that's the way I got to it. I got the prime factorization and the greatest number of times a factor is used in any one factorization. Then I list them and then multiply them, and that gives me it there. Okay, for something like this, we have to find the factors of it. So for this one, we will factor it. So the factorization of this trinomial is this. And here is the difference of perfect squares, which will factor into its conjugates. Now that same rule is used. What's the greatest number of times that this factor is used, x minus 3? Well, it's once in this factorization, once in this factorization, so once. Now 8 plus x plus 8, it's used once. And x plus 3 is used once. So if these were our denominators in later radical expressions, this would be our least common denominator. Okay, and if we multiply these together, that would be, well, that's what we're looking for, the least common denominator. Okay, as we look at number 12, and then later number 15, by the way, it was number 13 that I got a different answer from the book. I think they had meant to do number 13. I said, answer is okay, the one in the book, if the sign in the middle of this example is a positive. But the sign, as I have it printed, is a negative, so I think they might have messed up on that. But again, we're trying to give you some that are a little different and give you some hints on strategy. So as we look at number 12, we see this denominator is the difference of perfect squares. This denominator is also the difference of perfect squares, and the terms are the same, but the signs are reversed. So if we have reversed signs, what technique from chapter 5 did we say we could do? Well, let's write this one again. So it's t minus 8 over t squared minus 9. Now right now there's a negative there. But if I pull a negative 1 out of this, it becomes this, negative 1, and I switch them around. I end up with the same denominator, but I had to take out that negative 1. Now notice, I could make this a plus here and make that a negative up there. Remember I said we could do that. And now notice something. We have a negative divided by a negative. What's this going to become? A positive. Right. So we can take all of that away. And now this is our new example. So we now have, as we used before, I don't know if they want us to factor that. We're going to factor it anyway. It's going to be t plus 3, t minus 3, and this is going to be t plus t is 2t, a negative 8 plus 2 is a negative 6. Yeah, they do want us to factor it. Can you see what's coming up? This is where, I think the joy of math, if you can see it. I'm going to factor out a 2 here. This becomes then t minus 3. Look at that. So now the t minus 3's will cancel out, and I'm left with 2 over t plus 3, and that's the answer. Now, I don't know how long it's going to take you to do some of these, but again, I was at home with my booklet. They tell me the answers, but they don't show me how to get to the answers. So anyone, in order to get to the answer, needs to know the strategy, the protocol of getting there. All right, for number 15, take a look at that. It's got 3 terms now. But what will be your common denominator? Well, can you see that this and this are conjugates of this? So my common denominator then will be x plus 5, x minus 5, which is the factorization of this, which is what these are. So that's my common denominator. Now, in order to get these terms at the end to have the common denominator, I have to multiply this one by x minus 5. My mind is working ahead of my writing here. And x minus 5. Remember, this is 1. I'm multiplying this fraction by 1 in the form of this, so I get my common denominator. And then here, it'll be x plus 5. So now all of my fractions have this denominator, except I have to multiply through. And this is going to be 2x minus 10. Here this just stays the same. And as I did these at home, I would check my work, be sure I'm not leaving something out. Going to collect like terms here, I have a 2x, an x is 3x, 4x, a 7x. I have a negative 10 and a negative 1. That's what I was forgetting before. It gives me a negative 11 plus 20 is a positive 9. So it never hurts to check your work. There are many examples that I'm not going to do because, again, what I'm interested in here is to show you some strategies of how to do it. And again, some of these took me a while to do, and I don't want to make the tape too long. So, step number 1 is to figure out what our common denominator would be for number 17. So we're going to factor these. And fortunately, they're not too difficult to factor. In fact, I remember doing some of these before. So my lowest common denominator then, I'm going to need a z plus 3. I'm going to need a z plus 4 and a z plus 2. Now, since the z plus 3 is already there, I only need one of them. Okay, I think I'll change color. So what do I need to multiply this set to make it this? Well, I have to multiply it by that. And this one needs to be multiplied by this one, the one that's missing. And this negative sign can be a problem. So I'm going to make this a plus and put the negative there. And that's perfectly legal. Okay, now I'm going to multiply this through. And now this is a negative. And check your work. And that looks good. Now we're going to group like terms here. This is going to become a z squared. This is going to become a negative z. And then this is going to become a plus or negative 12. Or it stays that. Now you might think, well, that's the answer. If it were that easy. But notice this is going to be factored. Let's factor this. C, Z, 4, 3, negative, plus. Okay, well, I don't see any. Oh yeah, look at this will cancel out. Ooh. So what will our final answer be? Well, it's going to be z minus 4 over z plus 4, z plus 2. And this was number 17, and that looks like the answer. Okay. Wow. Now remember, if they wanted domain on this, z could not be a negative 3, a negative 4, or a negative 2. They didn't ask for it on this one. On the next one, they are. And what I'm trying to do is pick up examples where they're somewhat different, so if you get stuck, you could kind of do it. Okay, so number 21 is different. We didn't have any like this so far. Now you might say, well, what's our lowest common denominator there? Well, we have to factor this. We know it's going to factor into its conjugates. And this one already has a negative x minus 1. But this one doesn't have anything. So our common denominator is going to be x plus 1, x minus 1. So to get this fraction into this form, we have to multiply numerator and denominator by x plus 1. And if we want, we could make that a plus and put the negative there. That'll be okay, because that's just going to go right there. And we have to multiply this one by our common denominator. And I'm going to multiply it, and there's a 1 there, by the way. X squared minus 1. Okay. So I'll do this one. This is going to be plus x squared plus x. So I'm just multiplying this times this. And then this will be 3x squared minus 3. Now let's group like terms. This is a 3x squared plus 1x squared, 4x squared. And then this is going to be an x minus 2x, so that's going to be a negative x and a negative 3. Now again, you might think that's the answer, but this is factorable. So here, the x minus 1 can cancel out. So our final answer is 4x plus 3 over x plus 1. But remember, they want to know domain here. So x cannot equal a negative 1, or x cannot equal a positive 1. We call these restrictions. And with that, hopefully you have enough strategy. You'll be practicing, and each of these take a long time. So generally speaking, I don't give lots of homework on this, but depending on your teacher as to what they want you to do, good luck and keep plugging away.